Welcome to Electronics Specify Insights, the podcast for electronics engineers. I'm your host, Paige Hookway. In today's episode, I speak with Noman Hussain, Vice President of Software and Strategic Business Development at Pickering, about the continued relevance of read relay technology. The discussion covers the fundamentals of what read relays are and how they work, the types of applications and industries where they excel, and how engineers go about selecting switching technologies for their systems. Hussain also addresses common misconceptions about read relays, explores where demand is strongest today, and reflects on how customer requirements have evolved over time. I hope you enjoy this episode. Let's get started. Today, I'm pleased to be joined by Noman Hussain, who is Vice President of Software and Strategic Business Development at Pickering. So thanks very much for joining us. Why don't you start by just introducing yourself and telling us a bit about your background, please?
Hi, my name is Noman Hussain. I working for Pickering for the past 15 years, started as a programmer in Pickering and then worked through the ranks. I've worked on product development. A lot of my time has been involved in product development in Pickering interfaces. So Pickering is made of three different companies. Pickering Electronics, they make read relays. We design read relays for high-end instrumentation. Then we've got Pickering interfaces that take those relays, create modular switching and simulation modules. And then we have got Pickering Connect. So my role works across all three different areas in product development, in application development, and dealing with customers.
Fantastic. And perhaps for those that aren't familiar with Pickering, can you tell us a bit more about the company?
Yes, so Pickering started in 1968, Pickering Electronics. It started by John Moore, primarily designing read relays, high-end read relays. And that area of the business is still going strong. That's the reason we are here, and we'll be discussing read relays. Pickering Interfaces is started by Keith Moore, John's son, who took those relays, put it onto a board, and created programmable switching modules, where they've created modules that do switching and simulation, and primarily, again, used for ADE systems as well as mixed signal switching. And then finally, Pickering Connect, that was started in 2005. They design cables and connectors for these modules. So we have got a cable design tool that is responsible for sort of creating complex cables and cable assemblies. So we have got Pickering itself is very vertically integrated, starting from read relays all the way to designing subsystems. And we work quite closely with different OEMs and tier one manufacturers all around the world.
Excellent. So read relays are going to be the focus topic for today, and they've been around for a long time. So why does the conversation around them still matter today?
If anything, it matters more now than ever because the demand of test is increasing. And when I say that, the number of points that you need to test on a device is increasing. The challenges around the voltages, our currents are increasing. The finite measurements and the accuracy that you need to achieve is increasing. So evolution in read relays, who in the past or was just treated as a commodity product, the challenges around that is also increasing. In Pickering, we have built our expertise on for the past 50 years is geared around the engineering of read relays and how we can actually get the most out of that, what you call it, a passive component, so to say, and provide the best possible results from that piece of product.
So let's take a step back for a minute. You know, for people who may not work with them every day, what is a read relay and what job is it actually doing in a system?
So read relay, in essence, is a switch. It takes the signal from one end to the other. It's just like a normal switch in your house when you turn the lights switch on and off. There's a relay, there's a switching mechanism behind it that turns the power on and off. Relay is doing the exact same thing. When it comes to testing mechanism, what it's usually doing is transferring signals from your instrument, whether you are sending a signal to a device or whether you are measuring it. It routes that signal from one end to the other, and customers use that to design their ATE test system where they're moving thousands and hundreds and thousands of signals from one end to the other, and they have specific requirements based on the voltages, currents, frequencies, how they can actually achieve that. So yeah, in an essence, it's a very simple device, but you can achieve a lot from it.
And what kinds of applications are suitable for read relays in particular?
Oh, anything that requires testing from semiconductor testing to automotive and EV testing. If I give you an example, a couple of years ago, 3 years, 3 to 4 years ago, when there was a big EV boom,
Mhm.
the big read relays for charging of cars and onboard charging as well as charging of the grid station, a lot of read relays were used to sort of move the signals around there. Nowadays, we are seeing a big demand in semiconductor AI and GPU development, and read relays are getting used to sort of move the signals around to sort of test and validate the packages on different AI devices or AI chips that are getting created. It, it's got a variety of different uses. We have seen customers from oil and gas. We have seen customers using defibrillators and using relays in there for shocking. Yeah, a very simple device, yet it's got such variety of different applications that it covers.
Fantastic. So, from an engineer's point of view, then, what are they usually trying to prioritize when they choose a switching technology?
Engineers' perspective, what they're looking at is signal integrity. The signal that they're sending from one end needs to arrive at the other end without getting manipulated in terms of noise, in terms of capacitance, in terms of resistance. And if they can get a clean signal, and they can have multiple clean signals from that particular device, which means they don't need hundreds of those devices.
Mhm.
Those are the two things that they are looking for.
And how do engineers typically decide between different types of relay or switch technologies?
That's a really good question because when you are choosing or designing a relay, there is a bit of a hunch as well. Like, okay, if I choose this relay, how is this gonna perform in my circuitry? Because a lot of things are designed in simulation, but then when you create a board, there are physical world characteristics that can change the outcome. So what engineers usually do is we provide relay samples to a lot of our engineers. You can request samples free of cost. We also provide test results, so quite a few engineers reach out to us, to our relay experts, and then we sit with them, and then we look at their schematic, and then we talk about what kind of relay they can possibly use. So we discuss about different package sizes, what kind of currents, voltages, how to sort of place relays, what are the best practices of driving a relay. All of those areas we tend to work with the engineer to try and provide them with the best possible solution.
So, are there situations then where one technology looks good on paper, but in practice another ends up being a better fit?
Yes. I mean, goes without saying. I think trial and error seems to work really well. It's all, it's all good on paper until you actually start designing it, and then you look at the physical constraints based on the temperature. And they are based on the environment conditions, based on the moisture, based on there are lots of different areas that people don't capture right at the design phase, that they figure out right at the manufacturing phase. So it's always good to what we say is sort of do designs and iterations, try different things out, create prototypes. And yeah, rapid prototyping is quite key to some of these designs. We do rapid prototyping when it comes to read relays. We have got 3D printers that are printing cases for read relays, and we are sort of creating different kinds of relays to sort of trial it out before we actually make it into a final product.
So, what would you say then are some of the biggest misconceptions that people still have about read relays?
That it's a commodity, that you can just go to a distributor and pick a relay and put it on the board and it'll work as expected. No, that's that is far from it. I think if you want to design a good product, and if you want to design a product with safety in mind, you have to do your own research. You need to make sure you're selecting the right product. because it is quite crucial. I'll give you an example. If you pick a relay which doesn't have a magnetic shield and you put two of them next to each other, you drive one relay and there is a possibility that it will interfere with the other relay and the other relay will switch on. Now, if the other relay switch on when it doesn't meant to be and you've got something connected to it, it can cause catastrophe because you don't know what you've connected on the other end. And if there is something that is dangerous connected on the other end, it could be a fire hazard, it could be a risk to a lot of different things. So that's the thing. I mean, you have to be really careful when designing some of these products, and it depends. Some of these products, when they get designed, you don't have to worry about it because they are not safety critical system. But in other areas, if it's an aerospace application, if it's an automotive application where lives can be at risk, you have to be really careful.
I mean, speaking of applications, you gave us some good examples earlier, but I'm interested to hear where you're seeing the strongest demand today.
Today's demand mostly coming from semiconductor applications in AI and GPU development. We are seeing a huge demand around high performing relays, high frequency read relays, especially around small packet sizes. So we have recently released our relay, which end up winning few awards as well. The smallest 5 by 5 millimeter two pole, single pole, double throw relay in a very small form factor, and that demand came from having a semiconductor application where customer needed a lot of relay in a small form factor, but they want to make sure that everything works in harmony. So we designed that relay especially for that specification, and it has performed really well for us.
Fantastic. And I'm interested, given your experience in the field, what are customers asking for now that perhaps they weren't asking for 10 years ago?
The sort of things we are seeing more and more of is from measurement capabilities, because quite a few customers are now using our relays and designing them into their measurement devices. So low thermal EMF, that's been a big topic for us. How we can actually get the most out of the relay. Low leakage, we are getting a lot of demand from silicon carbide, so SiC and gallium nitrate transistor, high voltage, low leakage relays. That's been a big demand for us, and it's been quite challenging because sub 200 volt there are a lot of relays available that can get into picoamps, if not femtoamps leakage. But when you look at the high voltage relays up to 3 kV, 4 kV, 5 kV, primarily for the automotive market, there you still want to achieve the same femtoamp leakage. So that has been a really good design challenge for us, and we have got few products in our offering now that we are providing to our customers. So the applications are evolving. Basically, the power is increasing. So you used to have low power transistors, now you've got high power transistors, but the leakage and the other constraints still stay the same. So you have to sort of create a better product now than what you have, or you have to improve your product to try and meet the current demands.
And how much of the work today is about adapting to changing system requirements rather than reinventing the relay itself?
There's a lot of investment that has gone in creating a test system. We always talk about sort of providing a product that you can use to evolve your test system. We've got the same ethos when it comes to our modular instrumentation through Pickering interfaces, where we provide products that complement your system. So, I mean, if you try and reinvent the wheel now, and you leave away all the mature technology and the testing techniques and methodology, I'm not sure whether you'll be able to get any better unless there is a need for it. But currently, eh, anything that you design, you need to check the voltage, the current, the frequency, whether the device will perform under certain temperature, under certain altitude. Those are the things that will stay exactly the same. What we are seeing is the package sizes are changing. What we are seeing, the voltages are changing. What we are seeing, the frequencies are changing. But the concept and the principle stays the same.
So from Pickering's point of view then, what keeps this area of technology so interesting?
it's just the next customer application. We have got a relay that is in a satellite that is going around space, and it's done over 3,000 sort of 3,000 rounds around the globe. We have got relays that are defined in oil refineries where subsea, where where they are sort of conducting all sort of switching between the oil pressure. Yeah, we've got relays in planes, in cars. It's just whatever the next application is. Engineers are designing the next best thing, and then they are coming to us and coming up with their weird and wonderful applications, and we are then trying to sort of help them in the best possible way. So yeah, that keeps us interesting. That keeps us going.
And how important is it to keep refining a technology that some people might assume is already fully mature?
So it's purely based on the demand. We consider ourselves as a premium brand. We try to make sure that we are constantly evolving. There are new structures, new materials, new potting techniques that are coming out in the market, new automation techniques that are coming out in the market. We are trying to make sure that we are ahead of the curve. So if you don't evolve, then your product will lack quality. If you don't evolve, then your product will lack innovation. So from our perspective, if we don't evolve our products, then we will stay behind the curve. Yeah, that keeps us going. But more importantly, it's all come from customer demand. Like I mentioned earlier about our 5 by 5 millimeter relay for Singapore double throw. It's a really small form factor where you've got two switches. Well, you've got single switch that can switch to two possible
Mm.
connections, and that was based on a customer demand.
So if I ask you then, are read relays a thing of the past? What is the real answer?
Well, they were designed about 100 years ago. The very first reed relay in 1922. Pickering Electronics have been designing them since 1968. If anything, the demand has been stronger than ever. So it is a very very mature technology, but the constant evolution of it is what keeps us going. The
Mhm.
constant evolution of it, of us creating new products, is what's driving the future. A lot of innovation, a lot of technology, people who are designing different kinds of PCBs in and creating complex circuitries, that is getting driven by the testing that is getting done. And in those testers, you will find one or two read relays, if not hundreds of read relays. So the future very much relies on the technologies of the past, if that makes sense.
Yeah.
But
Yeah.
it requires an evolution.
Well, speaking of the future then, let me ask you one final question. What role do you see read relays playing over the next couple of years?
One of the things I've seen the huge demand from AI. You can see a lot of development going around, creating these data storage centers, creating these new AI chips that can compute data. But those chips that are getting designed, they need to be packaged, they need to be tested, and they need time to market needs to be faster than ever because the demand is increasing. Read relays will play a vital role in testing those, and the new testing methodologies that will come out will help sort of drive that. So yeah, as more things become electronic, like uh, our toaster used to be a simple thing, right? Now you've got Wi-Fi enabled toasters. So that's got microelectronics and sort of in there, and then that electronic circuitry needs to be tested as well. If everything around us is becoming sort of, what do you call it? It's smart.
Yeah.
Smart's the term that we are using these days. But Wi-Fi enabled and talking to each other. So if we are in this connected world, all of those devices needs to be tested. And when you talk about testing, you need a switch, you need a source, you need a measure. These are the three main things that makes a switching a test system that brings together. So yeah, if anything, the demand I don't think is gonna go until I retire. I think it'll go beyond that, to be fair, because yeah, there is no other thing out there that can that can replace it.
Yeah, no, very good points. And I think you've clearly highlighted that read relays have got a very important part to play in the future of technology. So thank you very much for joining me today and telling us more, not just about Pickering, but about read relays. It's been a real pleasure speaking with you, and enjoy the rest of your day.
Thank you very much.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.